Bismillahirrahmanirrahim. Force due to water flow, momentum and explosive forces. Force due to water flow. We know that when a stream of water or a flowing water in any canal or in anywhere, when the flowing water is suddenly stopped by some stopping agent, for example, the gates on the barrage, when the barrage gate is shut down, then water flow stopped. If this amount of flow is suddenly stopped, then this flowing water will exert a force on the gate of the barrage or the stopping agent. What amount of the force? Now we calculate that amount of force by using the formula. We know that in the previous lectures we have already proved that the rate of change of momentum is equal to force. And it's very simple. If you take mass common, then inside the bracket there will be Vf minus Vi. And Vf minus Vi is a change in velocity. So change in velocity over time is acceleration. So mass into acceleration is the force. So it is a very well established fact that rate of change of momentum is the force. Now we apply this formula to calculate the force due to water flow. If we assume that initially the water was flowing with the velocity Vi and it is suddenly stopped by the gate, then by putting the values of Vf and Vi in this equation, we get the result F is equal to minus m, as this term goes to 0, and minus mv, Vi is equal to V. So minus mv over T. So this amount of force is applied by the gate to stop the water and to make its velocity 0. So this is the amount of force applied by the gate or the wall which is stopping the water flow. As we know that this is a force applied by the gate, if we want to calculate the force applied due to the water, flowing water, then it will be equal in magnitude but opposite in direction because of action reaction phenomena. According to Newton's third law, the force applied by the gate will be equal to the force applied by the wall. Will be equal to the force applied by the water. So this amount of force applied by the flowing water will be equal to negative into negative. So negative into negative means positive. So total force applied by the flowing water on the barrage gate will be equal to m into V over T. Momentum and explosive forces. If we have a bomb and before explosion it has a mass but no velocity, it means that its initial momentum is 0. But as it explodes, after explosion, it smashed into pieces. So when a bomb which was originally at rest explodes and shrapnel flies every which way, each piece with a different mass and speed, the momentum vectors are shown in the after picture over here. If you see, there are different vectors. These are actually momentum vectors, and these represent the momentum of each piece. You see that the sum of all vectors ultimately goes to 0, as if we take the first vector as a pink vector or a blue vector, if we take blue vector as a first vector, or the first piece of the bomb, and second piece is shown by the pink vector, and so on. Ultimately, the final momentum of the last piece will be the orange, and it will meet at its terminal, or its head will meet the tail of the first vector. So net result is 0. So total momentum of the exclusive particles or exploded particles, the exploded parts of the bomb, the vector sum of those momentum will be equal to 0. In the second figure, you can see that it's very simple to understand. If the bomb initially has a momentum mv and shown by this vector, after explosion, if it gets into two parts, it explodes into two parts, then the total momentum of two parts shown by these two arrows, the vector sum of those two vectors, first one and second one, by taking head and tail rule, head and tail rule addition of these two vectors will result into a initial momentum before explosion. So it means that total momentum before explosion and after explosion will be equal. Either the bomb was at rest or bomb was moving initially. And the last topic, rocket propulsion. A rocket carries its own fuel in the form of a liquid or solid hydrogen and oxygen. It can therefore work at great heights, consumes about 10,000 kilograms per second of fuel, and ejects the burnt gases at the speed over a 4,000 meters per second. In fact, more than 80% of the large mass of the rocket consists of fuel. If m is the mass of the gases ejected per second with a velocity relative to the rocket, the change in momentum per second of the ejecting gases is mv. This equals the thrust produced by the engine on the body of the rocket. So the acceleration a of the rocket is, and this is minus mv over capital M. For the mathematical proof, we see that total force will be equal to mass into velocity per unit time, as force is the rate of change of momentum. And we know that change in momentum is actually 0 minus mv. Initially the momentum of the fuel was 0, and as it explodes or it's burnt out and exhausts from the rocket, then it gets a velocity mv, and in reaction to that the rocket moves up. So change in momentum is what? That is delta p. And we know that impulse is actually the change in momentum, and we know that impulse is equal to F cross T is equal to 0 minus mv. So force can be taken as, and as we are analyzing the change in momentum per second, so force is equal to mv per second. And we know that F is equal to ma. So acceleration is equal to minus mv over capital M. Dear students, thank you for watching the video, and please subscribe our channel for more informative lectures, videos, and please visit www.cancollege.com for more information.